Hi everyone, it's Ewan, and thank you for tuning in my first YouTube video. Today I just wanted to go over something extremely simple, which is unit conversions. You might have done this in the previous years, but down the line these are extremely important and need to be very efficient at converting one unit to another, because in problems you will be given different variables and these variables will not have the same unit and you'll have to use formulas, etc. So I have a few questions here for you, 5 questions which we can go over. So first question here, what is the area of a circular disc of 300 millimeters of diameter? Express the answer in the following units. So you can pause the video and answer it for yourself, but I'll just go ahead and solve it now. So, as we all know, the area of a disk is pi r squared pi d2. So let's just write this here. Is equal to pi d2. Sorry for the writing, I just had this new tablet with me. So that's 300, so we're using millimeters here, which will give us an answer of 70,685, Jesus Christ, 0.83. That's in millimeters squared, so that's actually part A. Right, for part B, so this was quite straightforward. For part B, you have two options. Option 1, you put the diameter in centimeters, so the area then becomes pi times, and then 300 millimeters is the same as 30 centimeters, so I just put that square over 4, and that gives us 706.86 centimeters squared. You're always trying to try and get 2 decimal places, which is kind of the standard. And option 2 is, you know that a millimeter is 10 power minus 1 centimeter, right? So 1 millimeter is 0.1 centimeter. Now a millimeter squared, this means that the squared is 10 power minus 2 centimeter squared. So if we use the answer from this question here, the area is equal to 685.83, 10 power minus 2, which is equal to the same answer as previously, 0.86 centimeter squared. So you can do it both ways, it doesn't really matter. The only thing is, obviously this is the quicker way, but sometimes the questions and the unit conversions are not that easy, as we'll see later on. And let's just go ahead and look at part C. Right, so part C, we wanted the area in square meters, so we'll do it just like the first. We'll just put the diameter in meters, which is 0.3. There we go, over 4, and that gives us 0.071 meters squared. There we go, fantastic. Now for the second question, now instead of talking about areas, we're talking about volumes. So for part A, calculate, and by the way, you can pause the video and same as before, answer it yourself, and I will go through it now. So compute the volume of the sphere with the same diameter, so that was 300. Although we know that the volume of a sphere, this time we might use the radius of pi r squared, depends how you, pi r cubed, depends how you were taught. Now we know that the radius is now 150 millimeters, half the diameter, of course. Right, so for millimeters cubed, is simply going to be 4/3 pi times 150 cubed. Now this comes out as quite a big number, which is 14,137,166.94. which is a massive number. And this is where you need to be good at unit conversions, where you need to see that you would rather have a smaller number. So there we go, volume, same thing as before. You could either put it in centimeters or in millimeters. So let's just put it in centimeters, which is 15 centimeters. Just going to bring it down by quite a bit. 14,137.17 centimeters cubed. And if we just do it like the previous step, we know that a millimeter is 10 power minus 1 centimeter. Now if we cube this, then we cube this, then 10 power minus 3 centimeter cubed. And so then it becomes the volume, is equal to 14,137,166, which is this answer, 0.94 times 10 power minus 3, which is equals quite a bit of stretch here to the same answer as before, centimeters cubed. There we go. And for part C, we're gonna have the same as before, 4/3 pi r cubed, which is 4/3, and the radius in meters, so 150 millimeters is 0.15 meters, and that's going to be equal to 0.014 meters cubed. Fantastic. Now let's go on the third example. A vessel in the form of a cylinder of diameter 100 and height 0.8 meters. What is the capacity of the vessel? Express your answer in the following. So here though is a perfect example where we have a variable in millimeters and another variable in meters. And so let's just go ahead and solve this question. So first part, volume of the cylinder. So we just know the volume is the area multiplied by the height. And so the volume here will be pi d squared over 4 multiplied by h. Now if we want the answer to be in millimeters cubed, then we have to convert the meters into millimeters, as this one is here, as we want all the variables to have the same units in the formula. So pi multiplied by 100 square over 4 multiplied by 800. So this is going to become quite a large number. So this is 2.83185.31 millimeters cubed. Sorry for the handwriting. Now for part B, now we'll have to change both of the units, or you use the previous way. So actually let's use it the previous way. Let's use the second method. So it's going to be equal to 6283185.31 multiplied by 10 power minus 3, which is the same as 6283.18 centimeters cubed. And finally, option C, we can go ahead and do the first method. So that would be the volume is equal to pi times, so the diameter, 100 millimeters is the same as 0.1 meters. So we're going to go like this. And the height is 0.8 meters. So everything's in meters, that's fantastic. And this is going to give us, well actually I just realized here, this is in liter, the answer in liters. Right, so actually this means we want it to be in decimeters cubed. Right, actually, never mind. Let me just go back a bit. So we want our answer to be in decimeters cubed, as if you know 1 decimeter cubed is the same as 1 liter. So decimeter cubed, 100 millimeters is the same as 1 decimeter. We're going to multiply by the height, which would be 80 decimeters. Now this gives us a 6.28 decimeter cubed, which is basically 6.28 liters. Here we go. This one's a bit tricky. You need to make sure I adjusted there to read the question correctly. Now for question 4, this gets a little more tricky. We get power of 4s. A beam, so this is most likely like this, an I-beam that you'll see later on, where we need to calculate the second moment of area for various calculations. So a beam has a rectangular section, rectangular section of depth 0.15 meters and a height width 0.025 meters. Calculate the second moment of area. So a second moment of area, BD cubed over 12. Once again, you'll start learning this by heart, so once you start actually seeing it in class. And so let's just go, since all our things are in meters and we're asked meters, it's going to be really easy. So the base is equal to 0.025 multiplied by the depth 0.15 cubed over 12. Now this is going to give us 7.03 times 10 power minus 6 meters 4. Now we want this result in centimeter power 4, so we're going to use the second method. So that's going to be 7.03 times 10 power minus 6, which is the answer we got here. And we know that the 1 meter is equal to 100 centimeters, or we'd say 10 power 2 centimeters. And so a meter's power 4 is the same as 10 power 8 centimeter 4. So now we're just going to replace it. That's equal to 10 power 8, which is equal to 7.03 times 10 power 2 centimeter 4. Or you can write this as 703, whatever you'd like. And finally for part C, same here, we can use the second method, which would be 7.03 times 10 power minus 6. So I'd recommend always using the first result you get, as for example, if you get the wrong answer for part B and then you use it again for part C, then obviously it's going to be wrong. So might as well just use the first answer, as it's most likely to be correct. You're not adding the errors along the way. So same as previously, a meter is equal to 10 power 4 is equal to 10 power 3 millimeters. 3. So a meter power 4 is 10 power 12, which becomes quite a lot now. Power 4. So this is 10 power 12, which is 7.03 times 10 power 6 millimeters 4. There we go. And final question. A rubber pad of circular cross section S of diameter d equals 200 millimeters to carry a load of P equals 3,500 newtons. What is the stress in the rubber, knowing that the stress is equal to the force over the area? Express the answer in the following units. Right, so the same thing, this is something you're going to see later on, something we use a lot, so it's really important to know how to convert these sort of units. So the first one's in newtons and millimeters. This is going to be quite easy. So the stress is equal to the diameter, to the load, 3,500 divided by the area. Now that the area is pi times the diameter. What kind of 2 is that? Over 4. Now this is going to give us a tiny number, 111, you can say, newtons per millimeters squared. Now for part B, this is where it becomes a bit tricky. So either you keep using the newtons in the numerator, but then you use your meters in the denominator, and it will give you newtons per meter squared, or you use the second technique. So let's try both techniques so you can learn. So that would, we keep the newtons at the top, but then at the bottom we want meters. So 200 millimeters is the same as 0.2 meters over 4, which is going to give us 111,408.46 newtons per meter squared. But if we use the second method, we know that the millimeters is 10 power minus 3 meters, and millimeter squared is this squared, so millimeter squared is equal to 10 power minus 6 meters. Now here is where you have to be careful, because you can see here this is at the denominator, and what happens when we have a denominator, when the exponent is negative at the denominator, it then becomes positive, if you remember your rules of powers of 10, for example. So let me just show you here. So that would be 0.111 newtons, that doesn't change, divided by 10 power minus 6 meters squared. So dividing by 10 power minus 6 is the same as multiplying by 10 power 6. So that would give me the same answer as above, 111.408.46 newtons per meter squared. I just add some extra space, and finally we want the answer in kilonewtons per meter squared. So let's grab this. So kilonewtons per meter squared. So same again, we could either use both methods. Let's go ahead and use the second method to see if this is probably the one where you would make the most mistakes, because this is where we do the biggest changes and conversions. So let's start with, we know that a millimeter is 10 power minus, we just did it above, so millimeter squared, 10 power minus 6 meters squared. And we also know that a newton is 10 power minus 3 kilonewton, and so a newton square, never mind. So these are both conversions we're going to have to do. So when we have 0.111 newtons per millimeters squared, it's the same as 0.111 newtons. We'll replace it by 10 power minus 3 kilonewtons, and millimeter squared is the same as 10 power minus 6 meter squared. And if we use the basic rules, so this is 10 power minus 3 divided by 10 power minus 6. It's like when there's a division, then the two power minus each other, if we can say it like that. So it's the same as 0.111 times 10 power, it's minus 3 minus 6, so it would be 10 power 3. I'll just make this a bit weird, but if you understand, so that would be 0.111 times 10 power 3 kilonewtons per meters squared. And so if you want to write it a bit more nicely, just 111 kilonewtons per meter square, and there you go. So I'm sorry if the video was a bit long. Hopefully that really helped you and understand all the different scenarios in which you can use these unit conversions. And if you have any questions, you can just post them in the comments, and I will be very happy to answer them. If not, if you really liked this content and this was helpful, please consider subscribing, and I'll see you in the next video. Cheers.